I'm going to tell you how to make special relativity work at singularities by reviewing a famous science fiction story. Poul Anderson lived from 1926 to 2001. His parents were Danish and he was a US citizen. He obtained a degree in physics and went on to write science fiction. He won many literary prizes and was a valuable contributor to US culture, as many birthright citizens are. His most famous book is Tau Zero, published in 1970. Notice the formula on the book cover. Tau equals the square root of 1 minus v squared over c squared. This formula occurs in general relativity and can cause a division by zero, which used to be a problem. Today we can divide by zero, which means that special relativity works at singularities. Tau Zero is based on the short story To Outlive Eternity, published in 1967. Poul's terminology was aimed not at professional physicists and mathematicians, but at general readers. I'll explain the jargon when I need to make the link from science fiction to science. The story also implicitly sets out the most egocentric solution to the Fermi Paradox I've ever heard. The Fermi Paradox says the galaxy is so full of stars and is so old, so why isn't it stuffed full with alien intelligences? I'll get to that at the end of this video, but here is how Tau Zero starts. After a nuclear war, Sweden is put in charge of all weapons of mass destruction and becomes the world's dominant political nation. Swedish becomes the international language of diplomacy, though English and Russian are used in science. In real life, the dominant scientific language is English. English is still the language of diplomacy, but with the USA abandoning leadership of the free world, that could change. This might be your moment, Sweden. There is a downside to Swedish administration. Earth is at risk of stultifying in a too peaceful era. To shake things up a bit, robotic and manned spacecraft are set out to assess exoplanets for colonization. In real life, the first exoplanet was discovered in 1992. That's 25 years after To Outlive Eternity, the predecessor of Tau Zero. And yet Poul correctly describes the astrometric methods used to find exoplanets today. Leonora Christine, a robotic spaceship with a crew of 25 men and 25 women, is sent to the planet Beta Virginis 3 to assess it for colonization. If it is unsuitable, the crew are to return to Earth with their scientific discoveries. But if it is suitable, they are to stay and colonize it, leaving the Leonora Christine in orbit as they use landing craft to make planetfall. The Leonora Christine, additional ships from Earth, or ships the colonists build themselves, are to be used by later generations of colonists in the onward expansion of mankind. In real life, 50 is probably too low a number of people to establish a genetically viable population by natural reproduction, but a sperm bank solves that problem, and we can imagine 3D printing sperm, so the actual number of people does not matter much. It might be better to start with a higher proportion of women. However, men generally handle short-term, high-level stress much better than women, and women generally handle long-term, low-level stress much better than men. So maybe an equal split is optimal. The Leonora Christine uses a ramjet that takes in hydrogen, burns most of it in a nuclear fusion Bussard engine, and accelerates the rest as reaction mass to add to the output of photons moving at light speed that are the main source of acceleration. The Leonora Christine has an acceleration of 1g, which is enough to travel almost anywhere in the visible universe within a human lifetime. The planned flight is due to last 32 years, but this will be just 5 years of ship time due to relativistic time dilation. This is a book of hard science fiction, so I'm interested to see how Poul Anderson handles the division by zero that drives the plot forward. Relativistic dilations of time, length and mass are all expressed in terms of the parameter tau, where tau equals the square root of 1 minus v squared over c squared. Here v is the speed of a vehicle, the Leonora Christine, and c is the speed of light. The closer v is to c, the closer tau is to zero. The dilations of time and length involve multiplying by tau. but the dilation of mass involves dividing by tau. So as the Leonora Christine accelerates closer and closer to light speed, the dilation of its mass involves a division by tau that is closer and closer to zero. Hence the observed mass of the ship grows towards infinity. This asymptotic approach to multiplication and division by zero drives the plot forward. A second way that division by zero enters into the story is that the closeness of tau to zero is measured by what Leonora Christine's crew call inverse tau. Inverse tau is written as tau to the power minus 1. It's equal to 1 over the square root of 1 minus v squared over c squared. Now as tau approaches zero, inverse tau involves an asymptotic division by zero and grows forever. Poul Anderson says that inverse tau has no limit. He means it has no upper bound, but it does, precisely where the title says. At tau equals zero, after the asymptotic approach to zero, transreal arithmetic gives tau to the power minus 1 equals 1 over tau equals 1 over 0 equals infinity. Indeed, transreal infinity is what mathematicians call the least upper bound of inverse tau. So transreal arithmetic makes more sense of the story tau 0. I've shown you how to draw a Trans-Cartesian coordinate frame. As usual, real numbers run along the horizontal and vertical axes. After a gap, positive and negative infinity occur as points, and nullity is a point that occurs outside the range minus infinity to plus infinity. I have put it at top right, but you can put it anywhere convenient. If you can draw a Cartesian graph of any mathematical or physical function, you can now draw the graph of that function in a way that allows division by zero. You can draw the solution at singularities. Many YouTubers could now make special relativity work at singularities. Zabina could do it, Up and Atom could do it, Tybes could do it. Maybe you can do it. If you're a PhD student in physics or mathematics, then read the paper on Trans-Newtonian Physics linked in the description below. Develop a Trans-Minkowski space and make general relativity work at singularities. I have absolutely no idea if that will be useful, but it will be an original contribution to knowledge. Then publish the results in the Transmathematica journal, or Nature. If you're an undergraduate student of physics, again, read the paper on Trans-Newtonian Physics linked in the description below and make special relativity work at singularities. This would be a good final year project. If you have a sympathetic professor, then write a conference paper on it. If you cannot find any other conference to take your paper, maybe the Transmathematica journal will. If you are a secondary school student of physics, you know what to do. Read as much of the paper on Trans-Newtonian Physics as you can. It's linked in the description below. Then rework your homework at singularities. If you have a sympathetic teacher, see how far you can get. But if you don't have the chops to do science, write a science fiction story on transphysics. Maybe you will accidentally do some real science, like Arthur C. Clarke did when he invented the geostationary communication satellite. And what of the most egocentric solution to the Fermi Paradox? Through a series of accidents, the Leonora Christine enters a new universe at its creation. The crew choose to land on a planet in a galaxy very early in that universe, so they are, quite likely, the only intelligent species. Maybe humans will go on to make the whole of the new galaxy and, perhaps, the whole of the new universe a human one. In that universe, there are no intelligent aliens, because they are all us.